Friends, here we are going to prove that there are infinite number of primes. Okay, we are going to prove this by the method of contradiction. So now let assume that if there are finite number of primes and say it be p1 p2 up to pk. Okay, let n be another number which is equal to p1 into p2 into pk plus 1, which is greater than all pi, which is greater than pi. If n is a prime and greater than all of this prime, so we have nothing to prove, because this shows that there is another prime which is greater than pk. Okay, so there will be an infinite number of primes. So if n is a composite number, then any of this prime will divide n. Okay, if any, suppose there is a for example, if 15 is composite, this will be divided by 5 or 3. Okay, any number also divided by any of the prime. Okay, if so, suppose pj, which is in between this p1 to pk, will divide n. So n can be written as some pj into t be any other integer. Okay, this n is this p1 p2 up to pj minus 1, pj plus 1, pj plus 2 up to pk plus 1, which is equal to pj. Now divide both side by pj. Okay, here pj will be cancelled, but here there is this term will be remain. Okay, here pj will cancel and it gives t. Here RHS is an integer, here t is an integer, but the left hand side, so the left hand side must be an integer. Because of this term, this is a fractional term. Okay, this is a proper fraction because 1 divided by any prime. Okay, so when we add to this, okay, it gives a fraction, and but the right hand side is an integer, so this not be, which is not possible because this not be a composite number. If this will be a composite number, then this pj will be divide this and gives a integer. Okay, but if this is a composite, this pj will must be divide this. Okay, since pj is not divide this, okay, this will not be a composite number. Okay, this implies that n must be a prime number. Okay, hence there are infinite number of prime. N is greater than all of this pk. Okay, and prime also, so there are infinite number of primes, because it is contradicted our